Okay, welcome to this video on 2010 Section B Question B3. Okay, on DCG. The 3D graphic on the right shows a metal geometric sculpture made up of a series of intersecting triangles. The horizontal and vertical coordinates for the outer points of two intersecting triangular planes ABC and ABD are given. So, here are the coordinates here. This is the X, Y, Z. So the X is how far from the end vertical plane, the Y is how far from the horizontal plane, and the Z is how far it is from the vertical plane. Draw the plan elevation of intersecting solids. Determine the dihedral angle between the planes, so their angle of intersection. Okay, determine the true shape of triangle ABC, and then determine the traces of the plane that contains triangle ABC. Right. Okay, so we're going to draw in our XY line. Okay, and then we're going to start a datum line here. Essentially, this is our YY line. This is the end vertical plane. Now, here are X coordinates. So there's 60. So A, and then B is 90. C is 120. And D then is 30. So that's all how far from the vertical or the end vertical plane we're going over. So that's like your YY line. You normally draw it heavy, but we'll draw it light in dihedral angle questions because you need the space on your sheet. Then we're going to do the Y coordinates, right? So point A, okay, is 20 mil up. So that's point A. Then B is 60 mil up. That's B. C is 20 mil up then again. And then D is 15 millimeters up. So that's all the Y coordinates done. Then D is not 15 millimeters up. That's the Z coordinate. My apologies. D is 70 millimeters up for the Y coordinate. Alright, so that's point D. Now we'll do the Z coordinate. Alright, so how far down? So D is 15 millimeters down in plan point D. Point C then is 70 millimeters. That's C is 70 millimeters down, so I'll label that C. Okay, B then is 40 millimeters down. And A then is 70 millimeters down. A. So we can connect them together. So one plane is ABC. So it says one plane is ABC and ABD. So ABC. So we can join ABC. And we can join ABD. So on plan and elevation. So I'm going to pause the video and heavy them in. So I am. I've them marked in. Now the next thing says find the dihedral angle between the planes. So the dihedral angle is the angle two surfaces intersect at. And that can only be seen when the line of intersection between the two surfaces appears as a point and the two surfaces appear as an edge. Now in order to get that to happen, you have to look along the true length of a line of intersection. So line AB is the line LOI, line of intersection. And line AB is not an existing true length at the moment because it's not a true length in plan because it's not parallel to the XY line in elevation. It's not a true length in elevation because it's not parallel to the XY line in plan. So what we're going to have to do is we're going to have to look perpendicular to the line of intersection. So I'm going to project an auxiliary looking perpendicular to the line of intersection. So I'm going to line up my set square with edge AB. I'm going to slide on my set square and I'm going to draw in my projection lines from the points. Okay. Now it doesn't matter if you project from an elevation or an auxiliary from your plan or elevation. That doesn't matter so long as you're going to see the true length of the line of intersection. So there, I've looked perpendicular to it. I can draw in my x1, y1 line, and I can take my heights from elevation. So I could take the heights with my compass there of D. So I'm going to take the height of D, put my compass on the XY line, lift, find D in plan, follow it along, mark it in there. I'll extend it in a moment. A and C are the same height, so take the height of A and C, lift, find A, mark it in, find C, and then I can take the height of B. So I'm going to mark B in there to follow or extend that projection line and extend this one. So this is A1, this is C1, B1, D1. Right, so if 2 points join in one view, they join in every view. So A joins to B, A1 joins to C1, as C1 joins to B1, B1 joins to D1, and D1 joins to A1. Right, I'm going to pause that and colour that in. Sorry, I forgot to pause that. So I'm going to look now along line A1B1, because if you want to see line A1B as a point, you need to look along its true length, and this is a true length because we looked perpendicular to it. That's why it's a true length. So I'm going to line my set square up with line A1B1. Slide the set square along, project these down, and then I'm going to draw in my x2, y2 line perpendicular to those projection lines. So that's my x2, y2 line. Okay, now I need to get my distances from my x1, y1 line back. So I'm just going to draw a datum line. I'm going to draw a line parallel to the x1, y1 line. And this is a datum line. I'm going to take my compass. I'm going to put my compass on the x1, y1 line. Bring the nib to D. Follow D1 up here. Bring it down. Mark it in. Okay, I'm going to do the same with A and B. So put my compass on the datum line. Bring it to A. Lift. Find A here, follow it along. So this is A2, B2. Okay, see they're the same. Now I'll do it with C. Put my compass on the x1, y1 line, bring the nib to C, lift, find C along here, follow C down. I'm going to mark it in. I'm just going to extend that on. Now, this is D2, A2, B2, and this is C2. Now, those points join together. So I'm going to join them together now. So this is the dihedral angle in here. So you want to get your protractor and measure it. So the dihedral angle is 168 between them. So 168 dihedral angle. You want to write that in. So this was an edge view with a peach surface. This was an edge view of the blue surface. So it was. Right, now, the next part of the question says, determine the true shape of triangle ABC. In order to see the true shape of something, you need to look perpendicular to it. So, the way we're going to find the true shape of surface ABC, I think the best way is to rotate it parallel to the x1, y1 line. So rotate it parallel to the horizontal plane. So here's ABC in elevation. Now, line AC is the true length in elevation because it's parallel to the xy line in plan. So, and if you look along the true length of a line, it projects as a point. So, and it's a true length in plan as well, because it's parallel to the xy line in elevation. So what I'm going to do is I'm going to project along line AC and I'm going to project B. So I'm taking the auxiliary elevation. I'm going to draw in an x1, y1 line. I'm going to take the heights from elevation. So I'm going to take my compass here. The height of B, mark it in there, and then the height of A and C. So take that height, mark it here. So this is A1, C1, and this is B1. So that pink surface, or peach surface rather, is appearing as a line. Now, this is an edge view of the horizontal plane and auxiliary elevation. So, what we're going to do now is rotate this surface until it's parallel to the x1, y1 line. So, I'm going to draw a line here from AC that's parallel to the x1, y1 line. Okay, and I'm going to rotate B1 until it hits it there. So, I'm going to rotate B1 until it hits it there, and this is it here. Now, B1 is moving our auxiliary elevation, so B1 has to move, or B is to move in plan. So I'm going to bring B1 back, I'm going to bring B down. So that arc in your auxiliary elevation appears as a straight line in plan. So this is B here, and A and C haven't moved. So this is the true shape of ABC. Okay, that's the peach surface. This is the this is an edge view of the surface. Parallel to HP. And this is it here. Now, the next part asks us to find the traces of the plane that contains triangle ABC. So if I bring this down here until it hits the x1, y1 line, that's a point view of the HT. So I can just simply bring this line, or this point view here, across heavy. So that's the HT. I must admit now, I should have done that in there. I should have left it there. You could do it in as hidden detail. So my apologies there. Now to get the VT. Right, so if I want to get the VT there, what I can do is, this is an edge view of the surface and this is an auxiliary elevation, so I can extend that on this x1 y1 line until it hits the xy line, and I can only do this because these are perpendicular, and I can bring this here, and this is a point view of the VT. Alright, right here, so that's the VT in plan on the XY line. In plan, the VT in plan is on the XY line. So to get this in elevation, I can take this height, lift, I'm just going to mark it up here, and it's a point view here, so it's parallel to the XY line elevation because it's on the XY line in plan, or it's a point view in our auxiliary rather. So here's my VT here. There's my VT there. You can't see that, sorry. So that's what the question looks like. That's the VT. Cheers, thank you, bye bye.